Hi everyone, this is Professor Oaks, and in this video we are going to discuss simplifying radical expressions. Alright, so most of you have probably heard of a square root, and a square root is an example of a radical. Alright, so here we have the square root of 80. Now, think about this, that if we had the square root of 81, we would know that that was 9. And if we had the square root of 64, we would know that that would be 8. But we really don't know what the square root of 80 is, right? So we either have to simplify it, or we need to just find an estimate of just saying, well, it's between 8 and 9 because 80 is between 64 and 81. But without knowing much else, we can't do anything, right? So here's how we would simplify these. I would use the prime factorization of 80. So as you can probably tell, there are a lot of reasons why we would use the prime factorization of a number, such as when we were finding the least common denominator or the greatest common factor. We would want to go ahead and find the prime factorization of all of the numbers or all of the constants. So we'll do the same thing here. So one way to write 80 is 8 times 10, and 8 is 4 times 2, 4 is 2 times 2, and 10 is 2 times 5. So 80 is 2 times 2 times 2 times 2 times 5. So the square root of 80 is square root of 2 times 2 times 2 times 2 times 5. Now, when I'm saying square root, it's like there is an imaginary 2 here, and that's called the index of the radical. All right, so then that means that in order for a number to come out of the square root, I need to have 2 of them. All right, so in other words, you can see I could rewrite this as square root of 4 times square root of 4 times square root of 5. But square root of 4 is 2, square root of 4 is 2, and then I have square root of 5. And then because there is a group of 2, do you see that was equivalent to that just coming out of the square root? All right, because square root of 4 was 2, and square root of 4 was 2. And then 2 times 2 is 4, so we have 4 times the square root of 5. And there's my answer. What a time to be alive. So let's go ahead and try this again. So square root of 600. 600 is 2 times 300. 300 is 3 times 100. 100 is 10 times 10. And 10 is 2 times 5. And 10 is 2 times 5. So square root of 600 is, all right, square root of 2 times 2 times 2. So 2 times 2 times 2 times 3 times 5 times 5. All right, so we have square root of 2 times 2, so that's square root of 4. And then there's another group of 2, so I have square root of 25. And then here I just have square root of whatever else is left. 2 times 3 is 6. So square root of 2 is 4. Square root of 25 is 5. And then I have 2 times 5 is 10. So 10 square root of 6. What a time to be alive. There's my answer. All right, let's try again. So here we have the square root of 175a to the 30. So here we go. So we have, well, all right, so 175 is 5 times, well, what is that going to be? That will be 5 times 35. And then 35 is 5 times 7. So we have square root of 175 will be equal to, oh, maybe I should have written that so long like this. All right, so that will be equal to the square root of 5 times 5 times 7 times a to the 30. All right, so remember that I could write this 30 times. 1, 2, 3, 4, 5, 6, 7, 8. 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. But really, because I'm looking for groups of 2 ways at a time, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 groups of 2 ways here. All right, so I could have just looked at this and said 30 divided by 2 is 15. Easy enough, right? All right, so I have the square root of 25 times square root of 7 times the a to the 15th power, and square root of 25 of 5. So 5a to the 15th square root of 7. There's my answer right there. What a time to be alive. All right, let's try another one. This one is a division problem, but then I see that I can take the square root of 98 over 64. That's really the square root of 98 over the square root of 64. And the square root of 64 is actually 8. But the square root of 98, so 98 is 2 times 49, and 49 is 7 times 7. So I have square root of 2 times 7 times 7, or 2 times the square root of 49, and the square root of 49 is square root of 2 times square root of 49, and square root of 49 is 7, so square root of 2 times 7 over 8, or 7 square root of 2 over 8 is my final answer right here. All right, so I hope that you are enjoying this so far. So let's look at another one here. So we have 110 x to the third y to the fifth under the square root times 44 x to the seventh y to the ninth under the square root. So I can actually combine these under one square root if I would like to. So here we go. So if I multiply these together, all right, now, by the way, remember that I really don't need to multiply the 110 and 44 together, because if I do, I get 110 times 44 is 4840, and then I would still need to do prime factorization. So like 484 times 10, and then 10 is 2 times 5, and then 484 would be, what's that, like 4 times 121, and 4 is 2 times 2, and 121 is 11 times 11, so that will be 2 times 2 times 2 times 5 times 11 times 11, and I would get the 2 2s and 2 11, so square root of 4 times square root of 2 times 5 is 10, and then square root of 11 times 11 is 121, so that's 2 square root of 10 times 11, and 2 times 11 is 22 square root of 10. Now, I could do it that way, or I could just take the 110 and do that, well, 11 times 10, and that's 2 times 5, and 44 is 4 times 11, and 4 is 2 times 2, so I have still 2 times 2 times 2 times 5 times 11 times 11, and I didn't have to work with all of the large numbers. All right, so if you like large numbers, and I know some of you like it large, all right, you like the large numbers, then you can go ahead and just multiply the 110 and 44 together first, but you'll still get 22 times the square root of 10. All right, so we have square root of 110, square root of 44, which we already know is 22 times the square root of 10. Then we have, under the square root, x to the 3 plus 7, 10th power, and y to the 5 plus 9 is 14 power. And then if you remember the last example, you just go ahead and divide the exponents by 2. So 10 divided by 2 is 5, so x to the 5th, and 14 divided by 2 is 7, so y to the 7th. And if I rearrange these so they're in front of the 22, I have 22 x to the 5th, y to the 7th, square root of 10. And there's my answer. What a time to be alive. All right, let's try another one. simplify and rationalize the denominator. Rationalizing the denominator just means to make sure that there are no square roots in the denominator, all right? Because square roots are generally, right, irrational numbers, like square root of 2 is irrational, square root of 3 is irrational, square root of 4 is not, but square root of 5 is irrational, square root of 6, square root of 7, square root of 8. These are all irrational numbers, and you don't want those types of numbers to be in the denominator. Or even square root of x to be in the denominator if you don't know what x is, because if x was one of these numbers, then the irrational number would be in the denominator. So you cannot have that. You do not want any of this irrational stuff in your life. All right, so now let's look at this again. So we have square root of a to the 29 over square root of b to the 7th, square root of c to the 11th. And yes, I can go ahead and break this all up exactly like this. All right, so now I look at all of these and I go ahead and I see here that I want to actually figure out what the square root of a to the 29th is. Well, I know that 29 divided by 2, so I'm dividing the exponents by 2 like before. Well, that 2 doesn't go into 29 evenly, but 14 with a remainder of 1. So this will be a to the 14th, and then that square root of a to the first power, or just square root of a, will remain on the inside. All right, let's try again. Square root of b to the 7th. Well, 7 divided by 2 is actually 3, remainder 1, so that will be b to the 3rd, and that b to the 1st will remain on the inside. And then the square root of c to the 11th, well, 11 divided by 2 is 5, remainder 1. So this will be c to the 5th, and that c to the 1st will remain on the inside. So what do I have here? I have a to the 14th, square root of a, over b to the 3rd, square root of b, and then c to the 5th, square root of c, and I don't need to write to the first power. All right. Now, here is where it gets a little bit tricky, so let me rearrange these for you. So I have a to the 14th, square root of a, and then I'm going to write b to the 3rd, c to the 5th, and make that square root of b, and then c. All right, I do not want the square root in the denominator. Remember I said I do not want any square roots in the denominator. I want to rationalize the denominator, which means to get rid of all of the square roots in the denominator. So how am I going to do that today? Well, if I had 2 b's under that square root, then they would be out of there. So what am I going to do? I'm going to just multiply by square root of bc over square root of bc. Because then in the numerator I have a to the 14th and then square root of a, b, c. And then I have in the denominator b to the 3rd, c to the 5th. But then I have under the square root b times b, b squared, c times c, c squared. And then I have a to the 14th, square root of a, b, c, and b to the 3rd, and then c to the 5th, but the square root of b squared is b, and square root of c squared is c, or b to the 1st, c to the 1st. And then I just go ahead and I simplify the numerator, so b to the 3rd times b to the 1st is b to the 4th, and c to the 5th times c to the 1st is c to the 6th. And then I see if those are any of my answer choices, and well, there it is. There's my answer choice. A to the 14th, square root of ABC, all over B to the 4th, C to the 6th. So what a time to be alive. I see right there that also has to be right because I rationalized the denominator. I got all of the square roots out of the denominator, and there you are. There you have it. All right, what a time to be alive. All right, let's try another one here. We have the square root of 90, x to the 27th, over the square root of 81, y to the 12th. So let's write this as square root of 90, x to the 27th, and then we have square root of 81, y to the 12th. All right, square root of 90 I can't do that. Square root of x to the 27th, I can't do that. Square root of 81, well, I know that's 9. And square root of y to the 12th, I know is 9 y to the 6th then, right? So, because remember, I had to divide the 12 by 2, and I get 6. So that's y to the 6. And I already knew the square root of 81 is 9. Now, I see then right away, the denominator is already rationalized, right? Because the denominator was a perfect square. Square root of 81y to the 12th was 9y to the 6th. So there we go. So now we just need to look at the numerator. So square root of 90. All right, 90 is 9 times 10. 9 is 3 times 3. 10 is 2 times 5. So I have square root of 3 times 2 times 5. And square root of 9 times square root of 10. And square root of 9 is 3. So that's 3 square root of 10. Then I have square root of x to the 27th. Well, 27 divided by 2 is actually 13 with a remainder of 1. So this is x to the 13th square root of x to the 1st, or just x to the 13th square root of x. So x to the 13th square root of x. And then I will rewrite this so that it is actually just 3x to the 13th, and then the 10 and the x are both under the square root, so square root of 10x over 9y to the 6th. And then I can go ahead and I can reduce the 3 over 9 to be 1/3, so it is just x to the 13th square root of 10x all over y to the 6th as my final answer. And here we go. 3y to the 6th is my final answer, because I said 3 over 9 was equal to 1/3, right? So I hope that you enjoyed this example here, and now is time for another one. All right, so what do we have here? Oh, this is a rough one maybe, because they give us a division symbol here. So make sure that you recognize that's a division symbol and not an addition. So again, if you're using Internet Explorer, you might need to zoom in more than if you're using, say, Chrome to look at that division symbol to make sure it's actually a division symbol. That's why I always tell you to use Google Chrome and not Internet Explorer. But anyway, here we go. We have the square root of 5x to the 18th all over the square root of 20x to the 4th, because that's another way to write division. And then this is the square root of 5x to the 18th over 20x to the 4th. And I'll simplify on the inside of the square root this time. So 5 over 20 is 1 over 4, so 1 over 4. And x to the 18th over x to the 4th is x to the 14th over 1. So I have the square root of x to the 14th over 4, or the square root of x to the 14th over the square root of 4. And the square root of x to the 14th, well, 14 divided by 2 is 7. So I know that's x to the 7th. And square root of 4 is 2. So it's x to the 7th over 2. What a time to be alive. So in this example, you saw that it was actually easier to go ahead and simplify the numerator and denominator inside of the square root. If, for some reason, you did not do that, then let's say you had square root of 5x to the 18th over square root of 20x to the 4th. Well, I know that's square root of 5x to the 9th over, and then that would be 5 times 4, so it would actually be 2 square root of 5x to the 2nd, and then square root of 5's divide out, so then I have x to the 9th over x to the 2nd is x to the 7th, so I have x to the 7th over 2 still. All right, so I don't know if you think that is easier, but I saw the other method first because I noticed that the 5 went into 20. All right, let's try another one here. So we have the square root of 16 over 3. All right, square root of 16 over 3. And it says to rationalize the denominator. All right, so square root of 16 over 3 is square root of 16 over square root of 3. And the square root of 16 of 4, so 4 over the square root of 3. And remember, I do not want the rational numbers or rational, I don't want these rational expressions to have radicals in the denominator. I want to rationalize them to make sure that they are like just rational like expressions, not like a radical and an irrational number in the denominator, right? So we're already dealing with rational expression because we're dealing with fractions, and then you want to put in irrational numbers in the denominator. That's crazy. All right, so now let's just multiply by square root of 3 over square root of 3, because that will get rid of that square root of 3 in the denominator, because that will make that square root of 9, and square root of 9 is actually 3. So now we have 4 square root of 3 over 3. What a time to be alive. All right, let's try another one. So we have the square root of 108 over 25. All right, so here we go. So I hope that you're enjoying this already. So I have square root of 108 over square root of 25. But I know square root of 25 is 5. Then I'll go and I'll prime factor 108, or find the prime factorization of 108. So what is that going to be? Well, that is going to be, what will that be? All right, so 4 times 27, and 27 is well, that's 3 times 9, and 4 is 2 times 2, and 9 is 3 times 3. So the square root of 108 is square root of 2 times 2 times 3 times 3 times 3. Or what do we have here? We have, well, we have a square root of 4 times square root of 9 times square root of 3, or 2 times 3 times square root of 3, and 2 times 3 is 6, so 6 square root of 3. So we have then 6 square root of 3 over 5, and there's our answer right there. All right, so now let's move on to the cube roots. So here we have cube root of 25u to the 4th v to the 7th times cube root of 40u to the 5th v to the 6th. So I'll rewrite this as one cube root. So cube root of 25u to the 4th v to the 7th times 40u to the 5th and v to the 6th. All right, so 25 times 40, that's 1,000. And then I have u to the 4th times u to the 5th, that's u to the 9th. And then I have v to the 7th times v to the 6th, that's v to the 13th. And then I'll find each cube root separately. So cube root of 1,000, well, this will be similar to how I found square roots. I need to look for groups of 3. All right, so I noticed that the cube root of 1,000 is 10 times 10 times 10. Cube root of 10 times 10 times 10. So it's cube root of 10 to the 3rd, which is just going to be 10. All right, so here we have cube root of u to the 9th. Just like I did for square roots and divide it by 2, I can do something similar for cube roots and divide the exponents by 3. So if I wanted to find the cube root of u to the 9th, I would do 9 divided by 3 is 3. So this is just u to the 3rd. So now I have the cube root of v to the 13th. So cube root of v to the 13th. I'll take 13 divided by 3. That is going to be 4 with the remainder of 1. So this means it's v to the 4th. And then the cube root of v to the 1st, or just v to the 4th cube root of v. All right, so I have v to the 4th cube root of v. And then, well, I just go ahead and I rewrite this in the final form here of 10u to the 3rd v to the 4th cube root of v. So there is my correct answer choice right here. All right, so in this problem, we're back to square root. So we have square root of 6a times square root of 8b over the square root of 12 times ca. So let's go ahead and break the square root of 8b down. So I know 8 is 2 times 4. So this is square root of 2 times square root of 4 times square root of b, and square root of 4 is 2. So 2 square root of 2b. Then I know square root of 12ca is actually the same as just square root of 12ac, and 12 is 3 times 4. So I have square root of 3 square root of 4 times square root of ac. and square root of 4 is 2. So I have 2 square root of 3 square root of AC. So now what I have is 6a, and then the 2 square root of 2b, and then I have the 2 square root of 3 square root of AC in the denominator. Alright, now I can see that the 2's divide out, and I can rewrite this as just square root of 3AC all under the same square root if I would like, but I don't want the square root to be in the denominator, especially again it said to rationalize the denominator. So that means to get all of the square roots out of the denominator and all of the irrational numbers out of the denominator. So the way we do that is the same way as before. We'll multiply by the square root of 3AC in the numerator and the denominator. So in the numerator, I have 6a, square root of 2b, square root of 3ac, and then I have square root of 3ac times 3ac in the denominator, so that 3 times 3, 9, then a squared, and then we have the c squared. Alright, so then square root of 9 is actually 3, and square root of a squared is a, and square root of c squared is c. So then if I look at what's left, I have 6a, and then under the square root, 2 times 3, 6, and then I have b times ac, or abc. So my answer is actually, where is it at? Well, I can see that the a's will divide out here, and then 6 over 3 is 2, so I have 2 square root of 6abc over c. So my choice here looks like it's choice C, the third choice down. All right, what a time to be alive. So let's try another one. We have the cube root of a negative 192. So again, remember that I need to go ahead and find the prime factorization here. So 192, that will be, well, what is 192? That is 2 times 96. So 2 times 96. And then 96 is going to be, well, 2 times 48. 48 will be 2 times 24. 24 will be 2 times 12. 12 will be 2 times 6. And 6 will be, well, 2 times 3. So 192 is 2 times 2 times 2 times 2 times 2 times 2 times 3. So 2, 2, 2, 2, 2, 2, 3. All right, so if I want the cube root of a negative 192, it's cube root of a negative 2, 2, 2, 2, 2, 2, 3. All right, so because this is the cube root, I need to look at groups of 3. So here is a group of 3, here's a group of 3. So I have the cube root of a negative 8 times 3. But then I know the cube root of 8 is 2. And the cube root of 8 is 2. And then I have a negative. All right, so I could actually make this cube root of negative 8, which would be negative 2. So that's also a possibility, all right? And then the 3 is left under the cube root, so the cube root of 3. And then negative 2 times negative 2 is negative 4, so negative 4 cube root of 3 is my final answer. What a time to be alive. All right, so now let's move on to the next problem here. All right, so here is the next problem. So it's a cube root problem again. So I'll rewrite this one as cube root of, well, 27a to the 17th, b to the 23rd, over cube root of 8c to the 21st. Then I'll split each of the cube roots up. So cube root of 27, cube root of a to the 17th, cube root of b to the 23rd, cube root of 8, cube root of c to the 21st. All right, so cube root of 27 is actually 3. And so, well, look here. that's 3 times 9, 3 times 3, so 3 3s means it's actually 3 to the first, which is just 3. And similarly, cube root of 8 is 4 times 2, and that's 2 times 2, so that's 2 to the third. So, so the cube root of 2 to the third is just 2 to the first, or 2. All right, then we have the cube root of a to the 17th. Remember, I divide the exponent by 3, so that will be a 5 with a remainder of 2. So this is a to the 5th cube root of a squared. So a to the 5th cube root of a squared. Then I have the cube root of b to the 23rd. I divide the exponent by 3, so 23 divided by 3 is 7 with a remainder of 2. So it's b to the 7th cube root of b to the 2nd. So b to the 7th cube root of b to the 2nd. And then I see the cube root of c to the 21st is just going to be, well, 21 divided by 3 is 7, so it's just c to the 7th. Alright, so now I go ahead and I just rearrange the terms a bit. So I have 3a to the 5th b to the 7th, 3a to the 5th b to the 7th, cube root of a squared b squared, all over 2c to the 7th. So where is my solution right here? It is the second choice on my list. What a time to be alive. Alright, so now it is time for the very last problem of this section, and it might look a little bit extreme to you, and it might look a little extreme to you because it is. It's the 10th root. So this means, just like for the square root, we divided the exponents by 2. For the 10th root, we need to divide the exponents by 10. So the 10th root of y to the 55, we have 55 divided by 10 is 5 with a remainder of 5. So this will be y to the 5th and the 10th root of y to the 5th. And then the 10th root of z to the 60th. Well, 60 divided by 10 is going to be 6. So we have z to the 6th. So we have a grand total here of, well, y to the 5th, 10th root of y to the 5th, all over z to the 6th. And we see that is the last choice right here. So that is all that I have time for on this section of simplifying radical expressions. I hope that you enjoyed this video and that you're already looking forward to the next one. Thank you and have a great day.